make me work harder, right? Make the teacher sweat. Okay, so the way we're going to do this is using something called elementary row operations. Okay, and there's 3 of them. There's 3 operations. The first one is that we can interchange any 2 rows. Okay? We can do that anytime we want. The next thing we could do is we can multiply any row by a non-zero constant. Now that non-zero is kind of important, right? I can't just multiply a whole row by 0, because that doesn't really help me any. It makes it true, but it doesn't help me get to where I want to be. The next thing that I can do is I can add or subtract, because subtracting is really the same thing as adding, right? If you think about it, it's just adding a negative. That's what subtracting is. Add or subtract any row by a non-zero, again, non-zero, multiple of another. And it's really, this is the one that we're going to use often. I mean, you can use them all, but this is the one where we really get to do some work and get our answer. So I'm just going to work through an example and identify a couple of things that that I'm doing. Anybody have any questions on those real quick? All right. So, example. So we want to solve the system 4x plus y is equal to 13, negative 2x plus 3y is equal to a negative 17. Okay? The first thing that I want to do is rewrite it in matrix form. Well, I'm already in standard form. I don't have to worry about rearranging these or anything. So I'm going to have the matrix 4, 1, 13, negative 2, 3, negative 17. Okay? Now, again, just to kind of give us an idea of where we're headed, remember, we're trying to get something that looks like this. So we want 0 to be here, 1s to be, this is called the main diagonal, okay? And then we want zeros everywhere else. So the first thing that I want to do is I want to try to make this a 0. So how can I make that a 0? If I multiply it by 2 and then add the row in front of it, these are the only things that I can do, right? I can add any row by a non-zero multiple of another. So if I multiply this row by 2 and then add this row, then I'll get a negative 4 plus a 4. That'll make it a 0. So that's exactly what we want to do. But we have a shorthand notation. Now, I'm not going to require you to write this out, although it would be very helpful when you're learning this. So I'm going to reassign row 2 is going to be equal to row 1 plus 2 times row 2. This is telling me I'm going to recalculate row 2 by adding row 1 to 2 times row 2. Okay? Now if I do that, now notice row 1 is not going to change, so I can just go ahead and write that all the way across. So the only thing that's changing is my row 2. So I'm multiplying it by 2 and then adding row 1. So 2 times a negative 2 gives me negative 4. Negative 4 plus 4 is 0. There's my 0 that I want. 2 times the 3 is plus the 1 for row 1. I've got to add in columns here. So 2 times 3 is 6, plus this 1 is 7. Now 2 times a negative 17 is a negative 34. I don't know, I didn't hear it. And then plus the 13 is negative 21. Everyone see how I did that? How many of you have done this before? You guys have? Have you guys done it before? David, did you have your hand up? No? Okay. Okay, so now this is one of elementary row operation that I did. Now again, let's look at where are we going. We want to we've got a 0 here. Let's make this a 1. So let's think about what can I do. I'm just going to rewrite it for now. So just rewriting this matrix at 4, 1, 13, 0, 7, 21. What can I do? What's one of these row operations that I can do to make this 7 a 1? I'm talking about row 2. Look at this one. I can multiply any row by a non-zero constant. That's the same thing as dividing. Multiplying and dividing is the same thing, just the way that adding or subtracting is the same thing. So what can I do to this row to make this 7 a 1? Divide by 7. So this is row 2 divided by 7. And remember, dividing by fractions is the same thing. Another way to say this is times 1 over 7. That's why we just call it multiply. If I'm dividing by 7, that's just the same thing as multiplying by the fraction 1 over 7. Now if I do that to row 2, it's nice. Row 1 again is just going to stay the same. Don't do anything to row 1. This is a 0. 0 divided by 7 is what? That's nice because we don't want this 0 to change. Okay, so we want the 0 to stay there. 7 divided by 7 is 1. 21 divided by 7 is 3. I think it's a positive. Oh, this should be a negative, yeah. Yeah, I forgot to bring this negative down right there. Anybody have any questions? All right, just a couple more steps, okay? With some practice, these row operations actually become fairly easy. So now I'm just going to bring this guy down. 4, 1, 13, 0, 1, negative 3. Okay? So again, I keep going back to this. A form like this should sort of be imprinted in your mind. You should always be thinking, this is where I want to go. I want to make my matrix look like this. I want to make it look like this using these operations. Well, notice what have I got besides bad handwriting? I've got a 0 and a 1 in the right place. I've got to make this a 1, and I've got to make this one a 0. Okay? I think it'd be easier to make this one a 0 first. Okay? Because if I wanted to make this a 1, what will I have to do? Divide by 4, and then I'm going to get these fractions here. Right? So to avoid some of the fractions, or at least try to, you may not always be able to, I can think of this is going to be an easier to make this a 0 first by doing what? So if I want to make this a 0, I can't just multiply it by 0. I'm going to have to do rule 3, right? So what am I going to do? Yeah, I'm going to subtract this guy. Because if I subtract a 1 from a 1, what happens? It goes 0. So the operation that I want to do is I want to say that row 1 is going to be equal to row 1 minus row 2. Now, I'm not changing row 2, so I can go ahead and write that. Now, row 1, this is also nice because 4 minus 0, that's what row 1 minus row 2. 4 minus 0 is what? 4. 4 minus 0. 1 minus 1 is, and then 13. Now here's, you got to be a little careful. 13 minus a negative 3. So if you need to do a little mini problem, do 13 minus a negative 3. What is that? 13 plus 3. The negatives, two negatives make a positive. This is 16. So this is going to be 16. Did you guys have that before I did? You already working ahead? Okay. Now what's the last thing I want to do? Divide by 4. Notice that it's going to be a little easier to divide by 4 now. Why? Because all of row 1 is now divisible by 4. So earlier I would have had this 13 divided by 4. That's not a good number. 16 divided by 4 is not too bad. So row 1 times a 1/4. This gives me the matrix. Well, 4 divided by 4 is 1. 0 divided by 4 is still 0. 16 divided by 4 is 4. And then row 2 doesn't change. So what's my answer? What's my solution? Four comma negative 3. Now, just to help you see that one more time, if you think about this as an equation now, so we started with an equation, we wrote a matrix, we did a bunch of matrix stuff, now we kind of go backwards, now we go back to an equation. This is the equation x equals 4, and this second equation is y equals a negative 3. And there's your point. X is 4, y is negative 3. Okay. So this is another way to solve a system of linear equations, rather than doing all the substitution and or the elimination. Are there any questions?